This is a production of Cornell University.
Good morning, everyone. Thanks, Lynn, for a very nice introduction. I'm also very fortunate to work with Lynn because she's an amazing weed scientist. And I think working together, you will see that in our presentation today, we are doing such a good job, I think, as weed scientists. So my presentation today will be really on novel technologies applied to specialty crop, on just showcasing some of the projects that Lynn and I have been working over the last 3 to 4 years with these new technologies. Do it this way. Just my background, very quick. I mean, like Lynn mentioned, I'm an associate professor on extension specialist in weed science for specialty crops. I have a three-way split where I'm doing research, I'm doing extension, I'm doing teaching, but basically it's 100% all the time. Especially this semester, fall semester for me is really big semester for teaching. I have 2 classes and I'm teaching in semester. In fall semester, I'm teaching weed science at Rutgers, and I'm also teaching an introduction to horticulture. So my research station is located at the Philip E. Marucci Blueberry and Cranberry Research and Extension Center, right in the middle of the Pine Barrens, so southern part of New Jersey. Initially, I did a lot of work on blueberry and cranberry, but over the years, I expanded that to specialty crops, including veggies and tree fruits. At the station, we have a very diverse group of researchers. We have people from USDA on Rutgers breeding, doing work on cranberry and blueberry breeding. We have a bioinformatician. We have a diverse team of entomologists, plant pathologists, and weed scientists, and we have also molecular biology as well. And since we are working on cranberry, we have someone from Ocean Spray, who is located on our research station as well. So yes, I mentioned it. What are specialty crops? You know, that will be the topic of what we are discussing today. But specialty crops, for me, in my opinion, are any fruits-bearing plant that is not soybean, field corn, or wheat, which doesn't exclude the fact that from time to time, I can do soybean work as well. But everything else, truthfully, for us in New Jersey is considered specialty crops. My research and extension focus is really on cranberry, because New Jersey is ranking number 3 in the US. Blueberry, we're ranking number 5. Peach, we're still ranking number 5 in the US. And in the veggies, New Jersey is ranking relatively high for pepper. So I did, in the last few years, I did work on pepper, cocker beets, asparagus, and I'm increasing my work on grape as well. Okay, when I was mentioning the Marucci Center is located right here in the Pine Barrens, but I have extension, I have research site in South Jersey, right here at Warwick, and I have also research site at Snyder in Northern Jersey. So different type of environmental condition between South Jersey and North Jersey, which is probably closer from what you have here in New York. So just, I mean, some of what we are doing in my research, in my weed science team at Rutgers. We try to understand the biology and ecology of various weed species that threaten the sustainability and profitability of major New Jersey specialty crop. We are looking at developing integrated weed management practices to provide effective and economically viable strategies. And definitely over the last few years, we have been doing a lot of work assessing the risk and benefits of new weed control technologies for New Jersey specialty crops. Yes, when we're looking at weeds, I mean, it's always good, but what we'll be discussing today in context, but why are weeds really important for specialty crops? Well, if you're looking at what would be the yield losses due to unmanaged weeds in some of the major North American crops, everything else being conducted perfectly, meaning that you're getting good fertilization, you're getting good disease and insect control. If you just let the weed compete, you're getting between 50 and 70% yield losses for some of these major crops. So for soybean, for example, that would be equivalent. I mean, we are losing around $17 billion each year due to weed management issues. Same thing for corn. Dry beans, over $700 million of yield loss caused by weed competition. So the direct competition for nutrients or water or any kind of resource is not the only impact of weeds. You have other impacts to consider. Some of these weeds will reduce harvest efficiency. Right here, you're looking at Palmer amaranth in corn. Look at the size of Palmer. Yes, it's me right here on the picture. I'm not small. Palmer can grow extremely tall. And when you're starting to get Palmer in a cornfield, clearly, when you will be harvesting, just the fact that you have Palmer will reduce not just your yield, but the speed at which you can harvest the crop as well. This one is a picture that I took in blueberry. What you see right here is dodder growing in blueberry, and dodder can be extremely parasitic and cause severe yield losses in blueberry just because it's a parasitic plant. So we have dodder in blueberry, we have dodder in cranberry. So yes, I mean, parasitism is something to consider. Some of these weeds can also be host for pest on disease, so that's something to consider as well. And the last thing is probably one of my favorite weed, just because it's in cranberry right here. So you're looking at cranberry. On everything that you see, which is kind of yellow brownish, is actually called Carolina redwood. I spent a lot of time before getting tenure working on Carolina redwood, and that was really interesting because cranberry is a really low-growing crop, and you have this Carolina redwood, which is overwhelming, dominating the cranberry canopy. So when you're applying fungicide, when you're applying insecticide to cranberry, most of the spray will be intercepted by the Carolina redwood. So just because you have the weeds, you will affect other management program as well. You will not get your insecticide, you will not get your fungicide where you need them to be. Okay, so when we're talking about weeds, herbicide is still the #1 solution for weed management. So in 2022, there was around 266 million acres of crops in the United States that were treated with herbicide. So it's a dominant, in terms of acreage, it's really the dominant pesticide that we're using for managing pests. However, this can be rapidly changing. It's a big problem that we are facing. Vipan and Lynn will not deny it because they are also working on that. But clearly, I mean, herbicide resistance is really a major issue that we are facing these days. There's 533 unique cases of herbicide resistant to 168 herbicides that have been documented in the US, meaning that herbicides that were at some point controlling these weeds at a specific rate are not controlling the weeds anymore because the weeds evolve resistance. Okay, they were able either by different way to survive this herbicide application. We have export market access, especially when you're starting to look at exporting to Europe. Some of these herbicides may not be accepted in other countries, so we may have restriction on what we can export to Europe or China, anywhere else. Consumer perception. I mean, more and more consumers are reluctant to the use of pesticide, including herbicide, of course. And the last thing, which is really to consider as well, is that, yes, I mean, when you're using a pesticide, it's not something which is neutral. I mean, you have to take into account the fact that you need to protect your worker. On some of these herbicides also, I mean, you heard about 2,4-D or dicamba drift. Some of these herbicides may be causing a lot of injury to other crop as well. So that's something to consider. That has been a problem in recent years with some specific herbicides. Increasing prevalence of herbicide-resistant weeds. Yes, many of the herbicide-resistant cases are known for soybean, corn, wheat, and barley, and rice. But if you're looking at specialty crop, if you're looking at our chart, we are actually #6 in terms of number of cases of herbicide resistance. So it's not just something which is for agronomic crops, it's also something which is affecting us in specialty crops. And just a picture of what we have in New Jersey, and Lynn and Vipan could probably draw the same table for New York. But yes, I mean, the first case of herbicide resistance in New Jersey was documented in 1980, smooth pigweed, resistant to the photosystem 2 inhibitor, atrazine, simazine, and metribuzin. And just last year, I mean, I documented a new case in New Jersey where we have goosegrass evolving resistance to glyphosate in soybean field, which is also a problem for us in specialty crops because many of these weeds will not just stick to the soybeans, they will move to other cropping system, especially if you're looking at New Jersey. We have a very intricate network of crop where you may have a soybean field, and next to it, you will get a blueberry field. So guess what? I mean, these goose grass species will love moving into the blueberry field. So that's something to consider. Horseweed, my team will be working on investigating horseweed resistant to paraquat, and potentially to mesotrione as well. So we have constant case of potential herbicide resistance that are popping up in New Jersey as well. The big game changer these days is also the fact that we have some new regulatory changes that we have to face, especially regarding the Endangered Species Act. So all federal agencies, including the EPA, who are registering a pesticide, must ensure that the actions they carry out, fund, or authorize does not negatively impact threatened and endangered species of their critical habitat. And one good example for us in the East, including New Jersey and New York, I'm going to it's in New York as well, the bog turtle is one of these endangered species that we need to consider in terms of protection and make sure that when you are using herbicide, insecticide, fungicide, the use of these pesticides will not be putting a greater threat on the species that are already endangered. So these days there is a new EPA Endangered Species Act work plan for herbicide that has been produced on. Basically, the plan will introduce some new restriction on the use of some of these herbicides. So our growers will have to face new mitigation measures for reducing spread drift, reducing runoff erosion, and potentially reducing any kind of other species measures that will reduce pesticide exposure to endangered species on their habitat. So clearly, I mean, if you're looking at the picture of using herbicides these days, we are getting into a different environment. So we'll not get the same freedom at using herbicide probably in the future. So clearly that can make herbicide more difficult to use. So we need to start looking at what alternative we can have to herbicides. So there was a paper published in 2018 looking at what would be weed management in 2050. We know that herbicides are not going away. We'll still need to use some of these herbicides. We don't know in some situations how to replace them. I also want to point out that we don't have any new mode of actions that have been released across large acreage on specialty crops in 30 years. So there is nothing in the pipe, basically. If you're looking at other disciplines in pathology, entomology, yes, they're getting new pesticide, new insecticide, fungicide. That's not the case for us in weed science. So that's also something which is stimulating the fact that we need really to look at these new technologies. Biological control, Lynn and I were in a class with Steve before, we are discussing that, but we don't really have biological control in weed science, okay? If you're an entomologist, you know that you can use some biological control for controlling insects. We don't have this kind of opportunity in weed science. There is work which is conducted on enhancing crop biology for improving the crop competitiveness. That's something that needs to be further developed. But most of what we're doing these days is really looking at these new tools and looking at precision agriculture and looking at robotic equipment that can be not replacing, but supplementing the use of herbicides. So that's what we'll be discussing today. And I will discuss 3 different types of technologies that I've been investigating. Lynn investigated the same kind of technology as well. So we'll be looking at targeted spraying right here. We'll be looking at autonomous seeder and weeder. And the last one, probably the most exciting one, is looking at laser weeder, using laser for killing the weeds. So the first one, which is really what I'm calling the optically targeted herbicide spraying, and that's something that we did in high bush blueberry, and Lynn conducted the same experiment looking at grape. So this kind of technology, well, my 2 principal collaborators, well, Lynn, of course, but I'm also, Lynn and I, we worked a lot with Ayerfour, with Roger Bat at Ayerfour, because this project was considered to be an integrated solution. So coming up with something that can be reduce the amount of herbicides that we are using. So Ayerfour was financially supporting this project, the project that I will present. So when we're looking at blueberries, there is different challenges when you're growing blueberries. The first one is that you're not working on a flat ground. You're working on hill rows. So you are working on 3-dimensional surface, if you want, which when you're applying herbicide, when you're applying anything to the soil may be more challenging. We have a lot of drip irrigation, and I've never been a big fan of drip irrigation. Why? Because you have a single entry point of water where you can wash off all the herbicide out of the soil profile. So for me, that's something challenging to work with. We have weed populations that are consisting of annual weeds. We can deal with that, but we have also a lot of perennial weed species. You're working with the perennial crops, and you will see that in weed science, many perennial weed species are really associated with perennial cropping system. And we don't have a lot of herbicides that can really tackle these perennial weed species. Something which is also to consider in terms of weed management for blueberries, that blueberries are developing from new canes. Okay, so each year you have production of new canes that will be the support of future production for the crop. So you need to make sure that when you are applying herbicide, you save these new canes. You don't damage these new canes, because otherwise you will jeopardize your your yield potential in the future. We have a relatively narrow for weed control, especially with post-emergence, because when you're looking at blueberries this way, when they're starting to be loaded with blueberry, what will happen is that many of these branches will start bending over the row. And when it happens, there is no way you can get any kind of equipment moving between the rows for cultivating or applying herbicide. So that will narrow the time during which you can apply herbicide. And definitely you can see it on this picture, but we really have a lot of reliance on cultivation on sandy soil between the rows, which is a challenge as well. Okay, so why blueberry weed control matters? Well, most of our blueberry in New Jersey are grown on sandy acidic soil with low water retention. The crop has a very shallow root system, which means that, yes, if you have any kind of competition, especially with the weeds, because you have really very low water retention in the soil, I mean, the weeds will be extremely competitive for pumping water. So, yeah, the crop is really highly sensitive to water stress, as well as disease and insect pests. So you really need to get good weed control, because yes, weeds can quickly be a problem. Weeds can be also pests and disease. I mentioned it before. And again, I mean, weeds can prevent proper targeting of insecticide and fungicide. And if you look at the next slide right here, you see what I mean. You're looking at horseweed right here growing in blueberry. And typically these horseweed, if they are not managed early on, they can grow taller than the blueberry, and they can really intercept any insecticide or fungicide, same way as I was showing before with Carolina redwood. Why do we have horseweed issues in blueberry? Because still many growers are relying on glyphosate for controlling horseweed, and this is a perfect case of herbicide resistance, of glyphosate resistance. We know that our population of horseweed are completely resistant to glyphosate. We cannot kill them with glyphosate. It takes time for growers to integrate the fact that they need to change their practices, that glyphosate may not be the solution anymore. All right, so when we are talking about optically guided targeted spray system for weed control, what may be the advantage of this system? Okay, when we're using herbicide, we want the herbicide to be especially post-emergence herbicide, the one you applied once the weed have emerged. You want this herbicide to be precisely located on the weed that you want to control. So if you're using something that can just apply the herbicide exactly where you need it, that would be great, because you can reduce the volume of herbicide that you apply annually. Instead of doing a broadcast application, you're just applying the herbicide where it should be. You're reducing the crop injury potential associated with post-emergence herbicide application, because you just apply the herbicide to the weeds. You don't apply the herbicide on a broadcast basis. What we did in this study is that we also try to evaluate new herbicides that are not specifically labeled for a crop using this system, because since you can potentially reduce the damage caused to the crop, you can eventually consider that new herbicide may be labeled, because you will reduce the amount of injury to the crop. And eventually that could be considered as a mitigation strategy for preventing off-target herbicide movement that could negatively impact T&E species. So again, I mean, you don't do a broadcast application, you just put the herbicide where it needs to be. So this system, the weed IT system, you can see it right here, used in agronomic crops, and I will explain the way it's working, but clearly you cannot apply this kind of system in agronomic crops, in specialty crops. If you want to work in specialty crops, we decided to use a smaller system, which is really mounted on this ATV, and you have a detection system right here, and you have the spray system associated with it. So very smaller system, but more practical, than using this kind of system. But again, the technology, the basic technology is the same. It's working. So the way it's working is that you have a sensor right here, which is emitting blue light. Okay, this blue light will be absorbed by the weed chlorophyll, by any kind of vegetation if you want, and in turn, after absorbing the blue light, the chlorophyll will emit near-infrared in reaction to the blue light. This near-infrared will be sensed by the sensor, and the sensor will actuate, will trigger a spray boom. So that will trigger the application of herbicide exactly where you detected chlorophyll. So you can see it right here. You have the sensor, which is located right here. You have the picture of the sensor projecting blue light on the ground, and it's divided in 1, 2, 3, 4 different sections. Each section is corresponding to a specific nozzle. So you have 4 different independent nozzles that can just independently apply herbicide where weeds have been detected by the sensor. So we had this project in 2022, both in New Jersey and New York. Lynn was working on grape, and I was working on blueberry. And again, this project was funded by IORFUR within the Integrated Solution Program. So our goal were really to evaluate the potential to safely apply novel or non-registered herbicide using a commercially available optically guided spray system. And we wanted to compare this system, the efficacy of this system, with a regular broadcast application. So we tested different herbicides, and I will not get into the detail, but basically we had references right here. Glufosinate was our standard herbicide that blueberry and grape grower can use. I was also using 2,4-dicolene in blueberry because it's labeled for use in blueberry. It's not labeled for use in grape. No. Everything in red right here was new herbicides that we tested to check if there was, if using this precision system would improve crop safety using this herbicide. And you had 2 different application methods, either bonded or using the weed IT system. So if you're looking at weed control in blueberry, 4 weeks after application, I look at 3 different major weeds in our blueberry plantation: groundsel, horseweed, purslane. We had similar level of weed control using either a regular bonded broadcast application compared to the optically guided weed IT system. So in terms of pure weed control efficacy, effectiveness, we had the same level of efficacy between the 2 systems. Where it started to be really interesting is that if you're looking at crop injury, clearly right here, that was grape canopy injury. Lynn observed increasing injury over time with some of this herbicide with a bonded application, which was not the case of vision-guided application. So the way we are thinking it's working is that, yes, some of this systemic herbicide may have been taken up by the plant, and because you do a bonded application, you have more herbicide that can be potentially absorbed by the plant compared to the vision-guided where you just put the herbicide on the weed. When you're looking in blueberry, we had a different picture in blueberry, okay? We saw, especially if you're looking at the new cane stunting, we saw more damage on new canes, more stunting associated with a vision-guided in red application as compared to the bonded application. On the zinc, my hypothesis is that definitely this kind of system, it's nice, but it's not artificial intelligence. You're just talking about a sensor which is detecting chlorophyll. So there is no difference between the chlorophyll of blueberry plant and the chlorophyll of a weed. So clearly, especially on the new canes, we applied herbicide on the new canes because it was sensed, it was detected as a green tissue. That you can see it here. We had 2 different types of application. We had the first application and the second application right here. In the first application, when the canes were relatively small, that's the canes right here, we got a lot of injury. The second application that came later in the season, we saw definitely less injury because the canes started to get bigger, so we are less exposed to the herbicide application. But that's what you can see on this herbicide. I think that this one, yes, this one was fluorpyroxyfen herbicide, and you can see that this new cane starting bending. It's a group WSSA group 4 herbicide, so you can typically see the damage associated with oxinic herbicide. So different, the way you're considering the system, if it's grape or blueberry, you may have different results using this kind of system. Did we achieve a reduction in the herbicide use? Yes, definitely. When I look at my data, we measured the volume of herbicide we are using. On looking at blueberry treatment, we save between 40 and 55% of the herbicide using this system. Again, I mean, we got the same level of weed control. The big problem we got in blueberry is that, yes, because it's not artificial intelligence-based system, you got injury to the new canes. So that crop injury gave us an idea, actually. In 2024, this year, well, yes, we conducted a new trial with Lynn where we are looking at evaluating the weed IT sprayer right here, using it in grape for controlling suckers. Okay, not trying to control the weed, but really trying to control the suckers. You don't want to get any vegetation growing on this trunk because that's nutrient that will not be available for where you want to get grapes to be produced by the plant. Okay, so we had two systems. We had a typical spray application. That's Wes, my technician, applying right here, applying herbicide when we're working on applying herbicide on the suckers right here. On the second one was using the weed IT sprayer. It's barely visible, but each time the weed IT is detecting the green on the trunk and is applying herbicide strictly on the suckers on the plant. So that's data coming from New York here. Lynn got the same level of sucker control between traditional on-sucker removal or using the wand or using the the optically guided spray system. The difference between the two was on the wand spray system, she used less herbicide compared to the vision-guided spray system, but it was mostly on this case because when they spray the herbicide, they spray both sides. Okay, when with the wand spray, they only spray one side of the plant. They didn't come back the other way. Now, if you're looking at, you did some further experimentation on this one, comparing one side application of the vision-guided sprayer versus two sides, actually, you're getting the same level of biomass reduction looking at these two types of applications. So the vision-guided one side will be providing the same level of control of a regular application. For us in New Jersey, again, I mean, you're looking at the percentage of fresh weight of the suckers as expressed as percentage of the non-treated control. On removal, we were at the end of the season at 6% of what you were getting otherwise without removing the suckers. And we got the same level with the weed IT sprayer, with the vision sprayer. If we were just using the wand, yes, we get significantly better control of the suckers, but at the same time, we use twice more herbicide doing that. So clearly, I mean, for the growers, is not, I mean, that's what they're doing. The on removal is typically what the growers will be doing. So they were, well, I mean, if we can save herbicide, go faster, just using the vision-guided sprayer, we are all for it. We don't need to have someone walking along the vine, along the rows to spray herbicides. So what next with the vision-guided sprayer? We want to get more automation. Cornell got a great idea. It's using this new robotic platform, the Farm NG Amiga, on try to get something fully autonomous. So transferring the vision-guided sprayer to a fully autonomous platform, so you can get application of herbicide without having someone driving the ATV, like I showed you before. So that's where we plan to go in the future with this system. Looking at autonomous platform, which is a second type of equipment that we are looking to investigate in our research. So we were looking at the NIO OZ autonomous platform. On it's a project that we conducted, yes, with Lynn, but also with Matt Bertucci on Claire Plasmeyer at University of Arkansas. So it's really a multi-state project investigating this new platform. So what are some advantages of robotic weeders? With this kind of equipment, you can really do weed prevention. You can do early detection and removal of the weed before they really start competing with the crop. This kind of equipment can be extremely precise. So we can have precise targeting on removal of the weed. You can reduce herbicide use, and actually what we are doing is that we are not just using herbicide, it's pure mechanical control. You have labor efficiency, you don't need someone, so it's fully autonomous. Scalability, you have big system like, the Farm Droid, and there are bigger systems than the Farm Droid, but you also have very small systems that can be adapted for very small farming operations. And the last one is cost savings. Yes, you have high initial investment when you're buying this kind of system, but later, based on reduced labor, on the use of pesticide, on reduced use pesticide, you can saving cost later as well by just using this kind of equipment. So basically, autonomous platform for me are mostly tool carriers. So you will see many of them fitted with finger weeders or shanks, anything that can mechanically control the weeds. On the one, what is really required with this platform is that you just don't want to use GPS. GPS is not precise enough. Okay, you need to get something that will give you centimetric precision. You're planting a crop, you want to make sure that when you're using cultivation, it's killing the weed, it's not killing the crop. And sometimes the weed can be growing extremely close to the crop. So you need what we're calling the real-time kinematic, which is really a next level GPS, if you want, where you're getting this centimetric precision that you need for controlling the weeds where they are. So that's what you have right here on the Nio hose, which is really a small robot, the one that we're using. It has a GPS RTK receiver right here. You have a toolbar in the back. This one is relatively small. It's only weighing 300 pounds. It's 100% electric. It's something also to consider. It's not based on fuel. It's really based on electricity. On autonomy, it has up to 8 hours of autonomy. So you can run it autonomously in the field for 8 hours. What you can do with it is that, yes, you can do weeding. Okay, you can do mechanical weeding by using O-blade and torsion spring weeders. You can use finger weeders. But what I really like with it is that you can use a seeder. So we have been using a single row seeder attached to the Nio hose robot. And I like it because you can create a map of your field. You have a GPS system on board. You can precisely locate where your rows, your corn rows, whatever crop you're planting. And later you can come back for controlling the weed between the rows because you know precisely where the rows are located. So we did some work over the last 2 years now. We got it last year. We are looking at the efficacy of autonomous mechanical weed control based on tools, application frequency, on weed density, diversity. How do you compare this kind of tools with standard chemical weed control? On what is a crop safety? And I will point out that right here, when you're working with something like cabbage, it's really important that when you're hoeing, when you're mechanically controlling the weeds, you're not damaging the crop because otherwise you will see yield reduction. So, we conducted trial in 2023 at Rutgers, Cornell, and University of Arkansas. New Jersey and Arkansas, we worked on sweet corn. On New Jersey and New York, we worked on transplanted cabbage. So you see right here, the Nio hose seeding corn, on right here, working the ground, tilling the ground between the rows of cabbage. 2 videos, yep. So right here, you see the seeding autonomously. No one is controlling the robot. It's seeding autonomously the corn. And later, again, it's fully autonomous. You have equipment which is coming just to control the weeds between the rows of the corn. All right, so what kind of data did we get? If you're looking at trial we did in 2023 at Rutgers, looking at the weed biomass, we tested different 1, 2, or 3 passes of the Nio hose. And when we were getting 3 passes, we were getting the same level of weed biomass reduction than using a standard herbicide application. So yes, it works in terms of reducing weed pressure. Lynn did the same work at cabbage last year at Cornell. 1 pass was sufficient, maybe not to provide the same level of weed control as herbicide, but significantly reduce weed biomass compared to an untreated check. Right here, it's again a different trial we had on cabbage at Rutgers. We did the hose, we did 4 passes. we compare with a standard pre-emergence herbicide, which is Prefar. We use Prefar on 3 passes of the robot, and we had gold tender right here. And clearly, 4 passes of the hose were sufficient to significantly reduce the biomass. And it was at the same level of what you would expect with a standard herbicide, which is gold tender. So it was working well for controlling the weed. The big thing, and I mention it because it's a big problem we still have to face with this kind of equipment, is that if you're looking at the yield, if you're looking at the cabbage head weight, clearly with 4 passes of the hose, we had a significant reduction in head weight. And the fact is that it's mostly associated with damage, mechanical damage that you're getting when you keep running this kind of equipment. You don't have enough, even if we have RTK, we still eat basically the transplanted cabbage. And we got sufficient mechanical damage on the cabbage for causing a significant yield reduction right here. And we saw that with the hose only. We also saw it with the Prefar herbicide plus the robot with it. When we're using just Prefar, we don't see this kind of damage. Herbicide didn't damage the crop. That's a trial that we did this year in sweet corn. Again, I mean, we were looking at pre-only, pre-emergence herbicide, pre- and post-emergence herbicide. And we had 2 frequencies of use for the robot equipment. We had either biweekly, twice a month, or weekly application. And when we are using weekly application of the hose, we are getting the same level of weed control as what we are getting from a standard pre-emergence and post-emergence herbicide application program. We had some weeds that escaped the Nayo hose robot, and essentially this one, fall panicum. Even with herbicide, it's a hard weed to control. And clearly, yes, this one, because it's emerging late in the season, the hose didn't do such a good job at controlling this one. When you're looking at ear weight and ear length, clearly, I mean, hose application, if you're looking right here at the weekly application of the Nayo hose right here, you have the same ear weight as what you will get from a standard herbicide application program. Now, if you're getting bi-weekly, definitely bi-weekly was not enough. So clearly, we need to have a frequent, almost weekly passage of this kind of technology if you want to get good weed control. Okay, what is next with this one? Again, we want to get more autonomy. We want to try to use new tools that we can integrate with this technology. Especially, there's 2 different types of tools that I think will be interesting for us. Lynn mentioned it in the introduction. I do significant work looking at cover cropping in veggies, and we have a hard time sometimes establishing our cover crop between the rows of veggies. So we know that using this kind of robot may be something that if we are using it with a spreader, we can potentially start seeding cover crops between the rows of crops in plasticulture system. The other one is that right here you have broccoli planted in red clover, and sometimes you have significant competition between the cover crops, the red clover, and the broccoli. And we are thinking that we had something for mowing the red clover between the rows. We will significantly reduce the level of competition due to the cover crop. So we want to test potentially a mower for reducing cover crop competition. All right, let's move to probably the most exciting ones, which is really the laser weeder, which is work that Lynn and I did last year, duplicated between New Jersey on Cornell, New York. So we worked with Travis Parker from Carbon Robotics using this laser weeder platform coming straight from California. So Carbon Robotics was founded in 2018 and its headquarters in Seattle, Washington. The units are made in the US in Detroit. And in early 2022, Carbon Robotics launched the laser weeder targeting large vegetable grower states. So Arizona, California, New Mexico, Oregon, Washington, Idaho. So right now, this technology has been mostly developed on the West Coast, not so much application, not so much testing on the East Coast. So laser weeders are on farms in at least 17 US states, including New York now, and 3 provinces in Canada, with expansion into international markets to follow. So the way it's working, I mean, what we got here for testing was this, I would call it the research unit. That was their protocol That was their prototype, sorry, that they planned to commercial, and finally they evolved towards something which is really attached to the tractor. So that's the commercial units, $1.6 million. That's what you can see in California, but some onion growers here, I forgot their name, the Tories, got one unit as well here in New Jersey. So that's the commercial unit which is working with the tractor. This one was initially developed for fully autonomous laser weeding. That's not the way they pursued, okay? They decided to get with something which is really attached to the tractor. So we end up getting this one for experimentation this year. So the way it's working, a nice video right here. So you have artificial intelligence on board, which is, I mean, you're projecting light. On the light will really help the artificial intelligence discriminating the crop on the weeds, identifying the weeds versus the crop. On this system is driving, directing lasers, and you can see some of them, you can see some smoke right here. When you have weed detection, the laser are specifically targeting the weeds and burning the weeds, okay? Yeah, you see right here, right in the middle. It's impressive because you will see some picture, it's not touching the crop. So you really have excellent discrimination between the crops on the weeds, and we didn't see any crop damage associated with the system. So it's quite impressive to see. Just a picture of what it looks like when you're using it. The first thing you need to know is that you need to use it on small seedlings, okay? So it's something that, yes, you need to use really, it's not a, you need to look at your crop when you're using this system. You need to know what is the size of your weeds, because that will determine the efficacy of the system. So right here, it's on broccoli. You can see that all the weeds that I circled in yellow right here, you can see the burning of the growing point on the weed. So it's really targeting not the leaf, it's targeting the growing point of the weed. So it's really precise enough just to do that. Right here, you didn't see any damage on the broccoli. Same thing right here, looking at some of the pea that I planted in New Jersey. You have the peas right here. I mean, these weeds are extremely close to the pea, and the pea was not damaged. Now, something which is interesting to consider too is that the system will give higher priority for controlling smaller weeds like this one, okay? Why? Because controlling a big weed, it's not so big, but it's already big enough. For controlling a big weed like this one, that will require too much energy for the system, too much time spending on this one. So they are giving priority to controlling the smaller weeds versus the bigger weeds. With the bigger weeds, I mean, you can always send a small crew to just hoe and remove some of these bigger weeds. So we had a trial in New York on New Jersey. We look at different crops. So we look at peas, we look at spinach, Lynn look at beets as well. We had different treatment. We had, of course, untreated weed check. We had pre-emergence herbicide in spinach. We had post-emergence herbicide in peas in New Jersey. We had pre-herbicide followed by laser weeding, and we had laser weeding alone for comparison. So when you're looking at our pre-pea trial right here in New Jersey, you're looking at the weed density 14 days after the second laser weeder pass. So we did two laser weeder pass during the season. You're looking right here at two different types of herbicide. One which is a standard, bentazone, a pyridate that is not labeled, but we wanted to use something different as well. And you're looking right here at the carbon robotic in blue. You have the laser weeder, the carbon robotic laser weeder. And clearly in terms of weed density, we had the same level of weed density as what you would expect from the standard herbicide, which is bentazone right here. The weed-free was cleaner, of course, because we were manually weeding the plots. Pyridate, not as much. It's something that we're investigating it, but not such great control with this herbicide. If you're looking at weed fresh biomass at harvest, again, excellent efficacy of the laser weeder. I mean, I was really mind blown by this type of application, is that you just do two passes and it was sufficient to give you the same level of control of what you will get with the standard herbicide. Now, if you're looking at yield, we collected the crop fresh biomass at harvest, and clearly what was really interesting also to check, right, is that we got the same level of crop fresh biomass with the laser weeder as compared to the weed-free. And that was not the case with bentazone. Even if we get good weed control with bentazone, this herbicide may still be causing damage to the crop. And later, it will translate into crop fresh biomass reduction. So advantage of the laser weeder right here is that, yes, you're getting the same level of weed control, but you don't get herbicide injuries that may be associated with herbicide. And when you're looking at the yield, yes, I mean, we had significant yield difference. I mean, the laser weeder was at the same level of P yield as a weed-free check and was significantly higher than what we got with herbicides. Looking at spinach weed control right here, same thing, looking at weed fresh biomass at harvest, excellent control with the carbon robotics, with the laser weeder. We don't have basically any weeds left over at the end of the season. Now, when you're looking at the yield weight, what was interesting as well is that you had the same level of, I mean, this spinach was weighing as much as what you will get in the weed-free, but right here, the dual herbicide plus the carbon robotic laser weeder, we had lower yield on this one. And again, that may be something that may be related to crop damage caused by the herbicide. And actually, that's something that Lynn demonstrated here in New York, where right here you have herbicide plus carbon robotics. And when you're looking at beets, on spinach, we definitely have lower emergence where you have herbicide or herbicide plus carbon robotics plus laser weeder, because this herbicide may have significant effect on the emergence of the crop. So that's really something interesting, you know, with something that we as weed scientists are not documenting enough, and that's the kind of experimentation when you can start to see that. Okay, so that was similar experimentation, the crop stunting, again, greater crop stunting in beets and spinach associated with the use of the herbicides. So what's next for the laser weeder? We'll continue laser weeder evaluation for early season use in crops that can be sensitive to herbicide injury, like beets and spinach. I think for some high-value specialty crops, like in my case, basil, that may be really something interesting to test. We don't have any herbicide in basil, very few herbicide, very ineffective herbicide. So using the laser weeder will be something interesting to do. A brief overlook at some other novel technologies. So I mentioned the FarmNG Amiga. So that's what they already did at Clarel, where they associated the FarmNG platform, autonomous platform, with a weed IT sprayer. So combining two of these technologies together to get something fully autonomous. I will be working, and Lina will be working as well with the Zaso Zap Weeder, which is using electricity. I didn't develop it today because I didn't do it, but Lynn did work with electricity. But that's something that we want to use for vegetable crops, for example, to get some smaller units for plot research. We did some demonstration with autonomous unit for weed control in grape. So you can see this one, that's a Nioted, fitted with finger weeders. At the same time, you have some pruning equipment. You see how fast it goes. It's fully autonomous. You're controlling the weed, you're working on the ground. At the same time, you're getting some pruning using this kind of things. That's something that we don't have on the East Coast. I don't think we'll get it anytime soon. But that's a Vulcan autonomous weeder, where actually you have cameras on board that are detecting the crop on actuating some fingers, if you want, for killing the weed between the in the crop. So what did we learn so far? These technologies does not necessarily eliminate the need for herbicide, especially pre-emergence herbicide. We still need some of these herbicide. Because they are not eliminating all the weeds, you may still need to get manual labor for controlling some of these weeds. Some weeds will escape. They are always escaping. There will always be a place where the weed will escape. So what selection pressure could we be imparting with this technology? That's something that we don't know. We know that for herbicide, we don't know it so much for this kind of technology. Not all alternative practices will be compatible with the new technology. As I said, I'm working with cover crop. How does cover crop will fit using some of these new tools? We don't know it yet. But we really think that there is a role for this tool, especially as companies are coming to the Northeast to test and modify their equipment. And again, we cannot place all the eggs in the same basket. Last slide. There's many questions that we need to address before seeing full adoption of this technology. The first one is the cost. not just the cost of the unit. The laser weeder is costing $1.6 million, but you also need to get additional services. Okay, you need to get GPS, you need to get RTK, you need to get Wi-Fi. What about local support? This is very high-end technology. Do we have the capacity locally to provide support for supporting this technology? Adaptability. Most of these technologies have been developed for the West Coast. Okay, different environment, different soil, different conditions, different growing conditions. So how does it fit on the East Coast? I mean, we have weeds that are emerging on a much more frequent basis than California, for example. We have much more rain. So how does it fit for us on the East Coast? Infrastructure and regulatory readiness, operation and safety of transportation. How do you transport some of these units? How do you transport a laser weeder here? I mean, is there any specific regulation that you need to use? If I'm starting to talk to Rutgers about using laser weeder, the next thing I know is that I will have people from Rutgers telling me, you have to be extremely careful, it can damage your eyes. So, you know, you have all this kind of regulation as well. Cellular service, internet service, base stations. So you have to get all this service available as well for using this new technology. On changing the nature of the labor. I mean, this is high-end technology, and not many people have been trained so far for using this kind of technology. And yes, I mean, we are living in communities where people are, you know, I mean, weed management is something that in Blueberry Farm, Veggie Farm in New Jersey, many people are still doing it manually. What will these people do if we start getting this kind of technology widely available? So we need to start thinking to that as well. All right, so future studies, we'll be evaluating new autonomous robotic platforms. So I plan to work with a farm in Jamaica. I will be working with electric weeder. We just ordered a Zap weeder from Zaso. I will be ordering, well, I ordered the XP Coffee weeder, and I will be using the Zap weeder as well. We'll be continuing, if possible, the assessment of laser weeding in high-value annual crops. We are also planning, we already did some work in cranberries, looking at hyperspectral imaging for weed detection. And I wanted to mention that Lynn as a leading PI on this one, Brad Hanson, myself, and other weed scientists, we received a CRI planning grant in 2024 for identifying the novel technology adoption barriers on drivers by surveying stakeholders on a national basis. So, all right, that's my funding and acknowledgement over the last few years. And yes, the dream team. Well, if we have time for any question. Yes.
Like in the Finger Lakes area, a lot of vineyards will maintain under vine vegetation. And I'm curious for the blueberry farmers in New Jersey, it's like the ideal weed management completely bare under the vines, or is there room for some like competition or ground cover?
So the question is that, yeah, for blueberry, can we get some weeds growing under the blueberry bushes? Okay, can we tolerate that? Answer is no, mostly because traditionally, I mean, yes, growers don't want, I mean, our blueberry growers don't want to see weeds in the system. It's also because, as I mentioned, we are growing blueberries in sandy soil with really low water retention capacity. You may have weeds competing. If you have a dry year, quickly enough, you will see the blueberry bushes dying. I've seen pictures from a drought maybe 20 years ago, where they had such high weed competition that the blueberry bushes were dying because, yes, I mean, the water you're providing, even with drip irrigation, will be benefiting the weeds, will even not be absorbed by the crop. So I would say it depends on the nature of the soil. You may have soil here where you have higher retention capacity. For us in blueberry, sandy soil, so water is penetrating through the soil very quickly. On low organic matter content, I mentioned that we do a lot of cultivation, which I think we need to change because cultivating the ground is just depleting the organic matter over time. So if you're combining both, definitely we have soil that cannot keep the moisture. Actually, we have a project where we are trying to change things by growing cover crops between rows of blueberries. The big challenge is that, again, you're working on on sandy soil, so you don't have so many cover crops that can fit in this kind of condition. And you're working on soil pH, which is 4.5. So many cover crop will not just grow well under this condition. Okay, so that may be challenging. Yes, sir.
If the machinery is so expensive, how do kind of small farmers and communities afford it? Is that like a rental scheme, shared?
The cost of the technology, that's a good question. I think right now, yes, I mean, you see adoption of some of these big technologies by big farms. And truthfully, I think that for us in New Jersey and probably as well in New York, as a smaller farms that don't have the capacity right now to adopt this technology as a farm. Maybe if they start to come together, maybe they can provide sufficient funding for that. I see two things. I mean, not every crop will be useful for this kind of technology. Doing the laser weeder, let's say in squash production, you don't make enough money. There is not enough profitability in squash production for adopting this kind of high-end technologies. Now, the thing that may happen too is that over the years, I mean, this kind of technology will keep evolving. And I expect that within the next 10 years, we'll start to see smaller units that can start to be affordable for smaller farms like we have on the East Coast. And it's, yes, I mean, again, this system has been fully developed for giant farming operation in California. We are coming here, they are coming here to see us, and clearly, yes, I mean, maybe a few big farms can adopt it on the East Coast, but the majority of the smaller farms, they don't have the capacity of doing that. But I mean, if you're looking at, yes, I mean, that's the case for laser weeder. If you're looking at the Nio hose robot that I was showing, it's $70,000. So you can have small organic farming operation. They are very small farm where they can start considering buying this kind of technology because yes, I mean, it's effective for weed control. It can be really effective. I mean, you have a steep learning curve with some of this technology. The Nio hose, I show you the slide where actually you have good weed control, but you're getting so much crop damage that, you know, I mean, you need to learn to use this tool as well and to make sure that maybe you can tolerate a little bit of crop competition if, you know, if you don't get too many crop damage at the same time.
You want to mention like the Amiga, the cost of the Amiga, and like the Owl.
Oh, you bought it, so you can.
So Terry was saying, yeah, the laser weeder is definitely an outlier, but we do have 2 units in New York, and we have 2 more ordered by growers in New York. There are some very high value large farms, but like the Amiga, I think the Amiga runs about 15,000. So it starts to enter a range where it does become more affordable. There are companies that are building smaller, more affordable units. And there are some people who have a push for open source systems. Guy Coleman out of Australia has built an open weed locator, which is basically an open source vision guided system, you know, and I think that runs about $400, but you're just going to have to be extremely talented with like building it, you know, building your own spray system. But there is kind of this potential to minimize the cost. And as Terry said, more companies are entering the market, even in the laser weeder market, using different lasers. And so the cost is expected to drop.
The thing too, when you are talking about the cost, is that you have the cost of the equipment, but you need to get all, you know, this technology, it's not just putting fuel in it. You need to get access to RTK. You need to get access to GPS. You need, in some case, to get base station for the Amiga, for example. You need to get these other services as well that sometimes maybe, you know, may not be available. New Jersey in the Pine Barrens, I don't have Wi-Fi. I don't have the good cell phone service. So if I don't have it on my own cell phone, I know that this kind of system will not be working as well too. So that's something to consider too. So I think we'll be there at some point, but the thing too, I mean, I didn't mention it, that many of these technologies, they are excellent engineers. They are not plant biologists, okay? These guys think that they're coming with new equipment. It will be wonderful. It will be working great under the East condition. They don't know what are the conditions. They have a tendency, it's changing, but they have a tendency of working as a company, and they don't always come to see us, university extension people. It's starting to change. Okay, we saw that last year. But initially, it was mostly driven by engineers. They may not have the focus on a cropping system, on weed management, you know, on weed ecology, weed biology, they may not be familiar with that. And it's something that you need to integrate, especially here on the East Coast, because, well, our condition, I mean, California, it's easy. They don't have rain. If you don't have rain, you don't have weeds. Here, it's a different challenge. Yep.
Did you notice the laser weeder? Did you notice the difference in performance when it was weeding annuals versus perennials?
So we didn't see the difference because we didn't have perennials. Oh yes, we have nutsedge. you had nutsedge. I didn't have nutsedge. So Lynn can talk about the nutsedge, but that's something that, yes, definitely is interesting to check, because you may make the assumption that the nutsedge, it's a tuber. So you can kill the one which is emerged, but you still have sprouting that may be coming from the tuber. So I don't know. I mean, did we see something on this one?
Yeah, we had regrowth of nutsedge. We killed some small ones, but this is the whole what do we leave behind, who wins, and perennials are going to be, no matter what system we use, perennials are probably going to rise to the top of the winner.
I think for nutsedge, because we're working on annual crops, nutsedge, what will be important is that if you're looking at the ecology of nutsedge, at some point during the season, May-July, the nutsedge will turn toward production of new nuts, new tubers for next year, instead of producing new shoots. So in terms of weed competition, if you can get the nutsedge at least under control up to May-July, we tend to see that, you will be good, because basically you don't have many clonal population coming from the nuts. So I think that's something that, yes, I mean, you may still get regrowth, but at least you will not get the giant, clonal patches of nutsedge that you can get if you leave it uncontrolled. Yes.
What do you think about the application of either the lasers or some of the other tech in more of an agronomic setting with a large scale?
Oh, that's a question for Vipan. That's a good question. I don't know I think for the laser weeder, and Vipan, tell me if you think otherwise. I think the laser weeder is really well adapted for specialty crops because they're also high value crops. Do you make enough money? Do you need, many of these agronomic crops? I mean, they still have a huge diversity of herbicides that they can use. They are not as limited as what we are in specialty crops. So they may not have the same need for laser weeding than we have in specialty crops. But what they have in agronomic crops, the targeted application that I was mentioning before, Blue River, for example, they have this kind of targeted application where clearly they will still rely on herbicide, but they will really, rely on lower rate of herbicide because of more precise application of the herbicide. But I don't know, Vipan, but I don't think that the laser weeder, it's not something which is explored for agronomic crops.
No, I don't think so. And it all depends on the cost of the technology, right? And the value of the crop, the high value crops, where you can spend $1.5 million. But soybean, wheat folks are getting $4, $5 a bushel. There's a lot.
Yeah.
They have more tools, other tools, herbicide tools, which is still working.
The laser weeder is also much slower than if you went to Blue River's talk last week. They were going, 10 miles an hour?
12 months.
12 miles an hour. The laser weeder is not doing that.
1.5.
They can't cover the acres.
Right.
But the leafy greens, they can cover
Yes.
the acres.
But going into the future, this is the future.
Maybe in the future, we'll see units that can go faster as well.
All right, I want to thank everybody for coming. For the graduate students here, there is a lunch provided with Dr. Besancon in 413. Yes, thank you. Thank you all. And if you have questions for Terry, you can reach out to him via email. You can get in touch with me. I can put you in touch with him. Thank you so much, Terry. And we are looking forward to 2025. We are already planning the projects. We think it's getting exciting.
This has been a production of Cornell University, on the web at cornell.edu.